Hey guys, this is Satish Rohit Singh and welcome to day 3 of Just Enough Python for AI. Let's get started. So today we will be looking at control flow commands in Python, which are basically conditions and loops. For conditions, we'll be looking at if-else statements, and for loops, we'll be looking at for loops and while loops. If-else is nothing but you are teaching your program to take decisions, whether to go left or right, whether to do this or that. And with for loops and while loops, you are teaching your program to do a task again and again and again. I believe the desire to automate a repetitive task was probably the primary motive for invention of programming. Now let's look at them one by one. Conditional statements let you branch out. You set a condition and the code decides which path to take. Let's look at if-else statement. An if-else statement allows your program to make decisions. The way it works is very simple. If a certain condition is true, do something else, do something else. Here is a real life analogy. If it's raining, grab your umbrella. Else, put on sunglasses. Now let's look at a very simple example. We are initiating a variable named isRaining to true. It's a Boolean variable. And right below it, we have a if-else statement. We are saying if isRaining is true, then print grab your umbrella, else print put on your sunglasses. Now since we are the one who has set this statement as true, this variable as true, we will meet this condition. We will get into this condition and we will print grab your umbrella. Let's try this. As expected, if isRaining is true and hence we printed grab your umbrella. Had we made it as false, what do you think will happen? We skip this line and we move to this line because this condition is no longer true. If isRaining is no longer true, in fact it's false, hence you are moving to the else statement and then printing put on your sunglasses. There's one very important thing that you need to notice here. The lines just below if and just below else are a bit moved to the right. That's called indentation. And in Python, indentation is not just for optics. It's not to make the program look better. It does make the program look better. It does look better, but that's not the primary purpose. In Python, indentation matters. So anything that is indented below a if statement is within the scope of that if statement. If I write something like print 2, what do you think will happen? Since our statement is false, it's not printing, we are still going here. But if we make it as true, now we are printing both these lines. So as long as the lines are indented, they are within the scope of if. If I had something here, print true. As long as these lines are indented, they are within the scope of else. So this indentation is actually a part of the syntax, and this is how Python understands what is within the scope. If I make it false now, if you will see that we are printing put your sunglasses 1 and 2. Now if I type another line saying print out, within quotes, out. Now since this statement, this print statement is no longer indented, it is not within the scope of else or within the scope of if. How do we know? Let's see. It gets printed with false as the condition, and it will also get printed with true as the condition. It doesn't matter whether is raining is true or false. This statement will always get printed because this statement is out of the scope of this if-else statement. So I hope it clears that indentation in Python really matters. This is what defines the scope of this conditional statement, and you will see further down that indentation also helps in defining the scope of the for loop or the while loop. If you compare with some of the other programs like Java or I think C Sharp, they would be having curly brackets. So anything within a curly bracket is within the scope of, say, if else. Anything outside of that curly bracket is outside of that scope. In Python, we don't have those concept of curly brackets. We use indentation. Indentation is everything that is required. Now let's look at the next part. What if there are many options? Now, till now we have seen a simple if-else statement. If a condition is true, do something. If the condition is not true, do something else. That's it. But what if there are more than two options? In this case, we use if, else statements. Now, different people pronounce this differently. Many people would actually say if, elif, else, but this elif actually stands for else if. And in many other languages, this elif is actually else if. They do write else if, not elif. It's up to you whether you want to pronounce it as elif or else if. That's absolutely fine. I will call it else if. So now let's look at a simple example. We have a variable named temperature which is set to 35. We are saying if temperature is below 0, then print brr, it's freezing. Else if temperature is less than 15, print it's chilly, wear a jacket. And then else print nice weather, go outside. What do you think will be the output? Let's execute this code. It's saying nice weather, go outside because yes, our temperature is actually neither less than 0 nor less than 15. It's actually, it goes to this part. It goes to the else part of the statement. But the point to note is that this is the way to construct a if, else statement. One more thing to note is that even though here I've just used one else if statement, you can actually use more than one. You can use as many as you want. I can say something like else if temperature is 25, then print something something. Then else if temperature is less than 35, print something. And then let me make this to maybe 30 to get into one of these statements. If you're wondering how I'm able to type so fast, that's autocomplete. I have GitHub Copilot on my VS Code. So as you can see, it's able to loop through each of these conditional statements and find the one that satisfies the condition and prints the appropriate statement. Since our temperature is 30, this would go in here and say, it's hot, drink water. Next is nested conditional. Okay, so it is allowed to have a condition within a condition, within a condition, within a condition. Think of inception of conditions. A simple example is right here. We are saying that we are again initiating a number to 10, and then we are saying if my number is greater than 0, then print something. And then we are saying within that statement, we are saying that if it is also divisible by 2, then you print the number is even. Else print the number is odd. I hope you're getting the structure of this if else if statement. If we execute this code, we see that it satisfies the first condition because this number is 10, it is greater than 0, it goes and prints this statement first, that the number is positive. Then it again checks if this number is divisible by 2 or not. It is, because it is 10, 10 is divisible by 2. So it also prints this statement. The number is even. This is a very simple example, but in real life programming, you would get certain use cases where you will have nested if-else conditions. Now let's move to loops. So we have two types of loops, for loops and while loops. We can use for loops when you know how many times you want to iterate or when you are looping through a set of items. Now let's look at a very simple example of for loop. So we right here have a list of fruits and it's called fruits. So we have apple, banana, chiku and cherry within this list, and then we are iterating through the items within this list using for loop. So we have for fruit in fruits, print fruit. Now, one thing to notice is that this fruits right here is nothing but the name of the list itself. This is mandatory, it has to be fruits. This has to be the name that you are iterating over. But this right here, this fruit right here is just a way to refer to items within the list, within the set. I'm calling it fruit because it is more meaningful, but it's not mandatory to call it fruit. I would have called it anything. Let's first execute this command once. Let's take out this done, it's not needed. Okay. So yeah, we are able to iterate over these 4 fruits within the fruits list. Now, if I say change it to X, and then obviously we have to change here as well because that's what I am printing. What do you think will happen? Will this code work? Let's see. It still works. Exactly same output. I can call it anything. I can call it ha 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 ha. It just does not matter as long as what you have here is same as what you have here. This is just a name for the items within the list. You are referring to the items with this name. It can be anything. We had it fruit because it was more meaningful, and that's how it should be in real programming. Even though there is no compulsion to call it fruit, calling it fruit makes it more readable. Now, again, you have noticed that the statements below for are indented. In a way, we are saying that this line is within the scope of for loop. Anything that is after this, print, say done, this print statement is outside of the scope of for loop. It gets executed irrespective of whether this for loop gets executed or not. Let's move to the next example where now we are looping through a range of numbers, not a list. So this range is actually a built-in class within Python. It is used to generate a range of numbers, sequential numbers. And when we say range 5, we basically are saying 0 to 5. But when it's 0, we don't need to specify it. If we say this, it's still a write statement, it will still work. Okay? If we take out this 0, it still works. So you don't need to specify 0. But it means that we are looping through a set of numbers which starts at 0 and ends at 4, not 5. So I think we have seen this before as well. The starting is inclusive. The ending, which is 5 here, is exclusive. So we end at 4. Let's reintroduce the 0 here for clear understanding. So when you look at something like range 0 to 5, it means that 0, the starting number is included, is inclusive. 5, which is the ending number here, is exclusive. It does not include the ending number. So we loop from 0 to 4. This range class will return numbers in sequence from 0 to 4. 0, 1, 2, 3, 4. And since we have a for loop here, we are looping through for I in 0, 1, 2, 3, 4. And then we are printing those numbers with a F format string. Let's move to the next example. Now here we loop through each number starting from 0 to 4. What if you want to skip a few numbers, or what if you want to only say print odd numbers or even numbers? There is a way. Using same range class, you can say that start from 1. So we are trying to print from 1 to 10, but in steps of 2, which basically means that we are trying to print odd numbers. So we are starting with 1. The start number is included. We don't go till 11 because the end number is not included. We go only till 10. And then we are printing every second number. So if you execute this command, you can see that we are printing 1, 3, 5, 7, 9. All the odd numbers. If we change it to 0, let's see what happens. All the even numbers. 0, 2, 4, 6, 8, 10. Up to 10. Now, this part is what defines the steps that you are taking. Here we are saying that print in steps of 2. We can say print in steps of 3. It will do like that. We can say print in steps of 4. It will do that. This is a way to print in steps or loop through a range of number in steps. Now, next comes the while loop. This runs as long as a condition is true. Now, see the difference between for loop and while loop. For loop is kind of deterministic. You know from the beginning how many times your program needs to iterate for loop. For while loop, you don't know the number of times, but you do know that there is a certain condition. As long as the condition is true, you keep on iterating. The moment the condition becomes false, your program should stop. It should stop iterating. Let's look at a simple example. So we are initiating count to 0 and we are saying while the count remains less than 5, you print counting and then the number itself. And then we are incrementing the count variable by 1. This, if you guys remember, is same as count is equal to count plus 1. Okay. So, as you can see, we looped through, we kept on incrementing this count and we kept on checking for each iteration whether the count is still less than 5 or not. And if it's less than 5, we kept on printing, counting 0, 1, 2, 3. Once the count was 4, this statement would make it 5. And then once it goes back and checks the while statement, if it checks if this is true or not, count is no longer less than 5 because now it is equal to 5. This statement does not hold true and we come out of this while loop. A very simple example, but I believe a clear example. Now that you have learned conditional statement, you have learned about loops, you can actually mix and match. See, the beauty of programming is that as and when you keep on learning new concept, you can mix and match those concepts together to build a complex logic. This right here, we are actually mixing for loop with if and else statement. So we are saying that you loop through 1 to 9. 10 is not included. Remember, 1 is included. So we are looping through 1 to 9 and we are checking if the number is divisible by 2 or not. If it's divisible by true, print the number is even, otherwise print the number is odd. So you see, 1 is odd, 2 is even, 3 is odd. It goes from 1 to 9. Now let's look at breaking and skipping of loops. Sometimes you will need more control over your loops. You would want to break out of your loop early, or if a certain condition is met. A real life example would be, think of a cricket match, a one-day cricket match, and your team is batting second. The first team has already made 350 runs in their 50 overs. Now you have 50 overs to make 351 to win the match, right? So as long as you don't score 351, the match will go on till 50 overs. That's your full loop, your full for loop, right? But if your team somehow manages to score 351 or more, say within 45 over or at 46 over, the match ends right there. It doesn't continue for 50 overs. That's the concept here. Even though there is a loop, there is a range, but if a certain condition is met, you break out of the loop. We will see this with a very simple example right here. So we have again a for loop starting from 1 till 5, not 6. Okay. And we are saying that if I is equal to 3, we break. So what would be the output? So we're starting with 1. We printed 1. Then we printed 2. And then the moment I becomes 3, we break out of the loop and we stop the iteration. That's the use of break. There's another concept where instead of breaking the loop, you actually skip the current iteration. So the difference between this script and this script is that, let's first execute it and see. When we had this break statement in between, it stopped at 3. It came out of for loop at 3. We only printed 1 and 2. Here, when we have a statement continue in between, it will simply skip that iteration. So it goes 1, 2, and the moment it becomes 3, it just skips that iteration and continues. So you won't see a 3 here, but then you have 4 and 5. Now let's look at some common pitfalls and tips. First is off by 1 errors. So off by 1 error occurs when a loop iterates 1 time too many or 1 time too few. This is common with incorrect range boundaries. Let's look at an example. So we want to print from 1 to 5, and very often, especially when you are starting your Python journey, you would write something like this. And you feel this is the right statement, but it is not, because this will print from 0 to 4, not 1 to 5. And I believe I have already explained why. So the right statement would be 1 to 6, which is here. If you execute this line of code, you will see 1, 2, 3, 4. This type of error is very common and happens very often even with senior folks. But just keep in mind the range, where it starts, where it ends. Next is infinite loops. This happens with while loops. So let's look at example. We starting with I is equal to 0. We are saying while I is less than 5, print I is less than 5. But we are never incrementing this I. So this condition always remains true. If we execute this cell, we will get into an infinite loop. You want to see? It's going on and on and on. The only way for me to stop is kill this right here, thankfully. But how many times did we print? A lot. Now, let's look. I'm just going to comment this out so that we take out the output. Okay. Now we'll look at the correct version. The correct version is this, where we are incrementing the I with 1 every time we go through this loop. So if we execute this cell, you will see that we only print 5 times. Because the moment I becomes 5, we come out of this while loop. Okay? So the next pitfall is over-nesting. We previously saw that, in fact, we can nest our conditions. We can nest our if-else conditions. And you can have as many layers as possible. The program will never complain. The program will execute if the logic is right. But your eyes will complain. It will not look good. So the idea is to keep the logic simple and try to avoid nesting as much as possible. Over nesting will make your code hard to read and maintain, even for yourself. When you come back to read your own code, you will find it really hard to understand. So it is beneficial to keep the logic as flat as possible. Let's look at an example. This right here is a nested loop, nested if else condition within a loop. Let's execute this. Well, that's great. Let's look at the code once. We have a list named numbers, which contains numbers from 1 to 5. And then we are saying for number in numbers, that's great. A for loop. We are saying if these numbers are divisible by 2 and if they are greater than 3, we print even and greater than 3. Else we say even and not greater than 3. And then we go to the else part of this if statement, and which says if the number is greater than 3. So for example, here it was divisible by 2. That means right here the number is not divisible by 2. And then if it's greater than 3, we say odd and greater than 3, or else odd and not greater than 3. Oh my goodness. This is your nested code, right? But it could be simplified. We can actually club these two conditions together with a AND operator in between. The output is still the same, but we can see the code is a simpler version of this nested code. Keep your code as flat as possible. Now let's look at some common use cases of loops in data science. In fact, loops are used a lot. Loops are used in data cleaning, data pre-processing, and feature engineering. I'm not going through these terms in details right now. If you know them, well and good. If not, then also well and good. We will go through them in details in future sessions. But in case if you know, feel free to write your understanding of these terms in the comment box. I would love to hear some of those comments. Loops are in fact everywhere in data science workflows. You will even use them inside your machine learning models when tuning hyperparameters. Don't be bothered if it makes no sense to you right now. I also have a few quick exercises for you. Nothing very fancy, all simple questions. I'm pretty sure most of you will be able to get through this. But if you are stuck somewhere, if you're not able to understand the question itself, or if you have tried enough but still not able to get the output, do type in your issues in the comment box. I will personally try to address them all. The solutions to these questions will be present at the end of next video, but don't wait till the next video. Do try these out. And as promised, the solutions to the previous video is right here. The first question was to create a variable to store your favorite number or movie or desert. And then the next one was to check whether the number of days in the month January is greater than 30 or not. So my favorite number is 7 because Thala for a reason. My favorite movie is Inception, and January is a 31-day month. So I'm just checking if 31 is greater than 30 or not. And I'm storing that value, a Boolean value in a variable named is long month. Let's execute this statement and we get the output. The next question was to write a program to calculate the area of a rectangle with length equal to 5 and width equal to 10. Don't ask me whether it's centimeter or inch, it does not matter. And then add two strings together to make a complete sentence like Python is fun. The solution is right here. Length is 5, width is 10. We have a new variable named area, which is length into width, and then we can print the output. The area of rectangle is 5 into 10, 50. And then the next question First part of the string is Python is, the second part is fun, and then we are adding them together, we are concatenating them together, and then we are creating a sentence and we are printing the sentence. Python is fun. The next question was mess around with the type method by using it to confirm the types of variables. Now, till here, we have in fact created a few variables. We are going to use those variables. So we have a favorite number, favorite movie, is long month. Then we have, I think, area, and then we have sentence. We're going to use all of them in this question. Let's execute them. And as expected, favorite number, which was 7, is int. Favorite movie was Inception, string. Is long month was true, and its type is boolean. Area, which was 50, is int. And the sentence, which is this sentence here, Python is fun, is again of type string. The last question was to have some fun with string slicing. Print out only the first half of your favorite word. Well, my favorite word is Python. What else it could be? Let's look at the solution. Let me first execute this command and then we will understand what's happening. So my favorite word was Python, a 6 length word, and the first half is PYT. So we got the answer right. Now let's see what's happening. We needed to find the length of this string so that we can decide what the first half is. And for that, we have a built-in function called len. So this part right here, len, and then within bracket, favorite word, returns the length of this tree, which is Python. So this part will return, to be honest, 6. And then we are doing a floor division by 2. Let's think of floor division as division for the time being. So we are dividing 6 by 2. Hence, this half length variable will hold 3. And then what we are doing is that we are starting from 0. Since we haven't defined the starting point, we are starting from 0. So index 0 and till half length is 3, but 3 is not included. Remember from the previous day video? So we're starting from 0 and going 0, 1, 2, that is index 0, then index 1, and then index 2, PYT. This is what gets returned to first half, and then we are printing this. Now let's look at this floor by division, right? What's the difference between normal division and floor by division? We were lucky that our string Python is of exact 6 length. And when you divide 6 by 2, you get a whole number because 6 is divisible by 2. So you get 3. But what if my word was Pythons? And then if you divide the length of this string, which is 7 now, by 2, you will get 3.5. But what exactly is 3.5 in our use case, right? It's nothing. I mean, it's not right. We don't have 3.5 characters. We can either have 3 characters or 4 characters, but we cannot have 3.5 characters. So when we do a floor division like this, what it does, let me just execute this code. We're still getting the same output, that is PYD. The first half as per this code is still 3 characters. That's because when you do a floor division, it only returns the integer part of the result. So when you are dividing the length of this word, which is 7, by 2, a normal division would return 3.5, but a floor division will return 3, only the integer part. It skips the decimal part. And then we get 3. And that's the reason we are still getting PYT. That's the difference between a floor division and a normal division. In our use case, floor division made more sense. That's it. This brings us to the end of today's session. The next video is very important. It's about list and tuples. I'll see you in the next one. Happy learning.